Welcome back everybody. In this video we're going to take a look at using XPath to extract data from HTML. It's going to be an additional tool to our arsenal where we already know or at least have an idea of how to use Beautiful Soup. We also know or have an idea of how to use CSS selectors. Now it's time to add XPath, and why it's valuable you'll find out in just a minute. Let's open up our browser. Here we have the Beautiful Soup documentation. And what I'm going to be looking for is XML. There is a section here that says that we can install a parser like LXML or perhaps HTML5lib. The reason I'm highlighting here is firstly because LXML is something that we're just going to skim over because there is a library that we're going to be covering today that uses LXML under the hood. However, you can take LXML or you can take this HTML5lib, and the strategy pattern that we have been using in the two videos to basically just substitute how we're getting the opponents, this pattern is applied here. You can instantiate your Beautiful Soup with either LXML or HTML5lib. On the surface level, the way that you're using Beautiful Soup, everything remains the same. You change one string and Beautiful Soup internally starts doing things completely differently. The power here is that perhaps LXML is faster, perhaps HTML5lib parses HTML a little bit better or safer, or some HTML isn't complete and HTML5lib is still able to handle that. Those are the kind of trade-offs that you could be basically just substituting into your process by just changing a strategy. But anyway, let's take a look at LXML, what it looks like. Here we're gonna have a website and we got a little cute snake here. Mainly what I want to highlight here in the table of content sections, LXML can still do CSS selectors, parse, HTML. And if you are just confused by the word XML, don't worry, we will get to it in a minute. What I want to show you is just that this library is used to execute XPaths on HTML. So if you have some kind of HTML loaded, you can call .xpath and then an XPath expression. So same as you had to learn an additional sort of language by using CSS selectors, with XPath it's another language that you kind of have to learn. It's similar to CSS selectors, but it is really its own thing. The reason we're not going to be using LXML directly, but however we're going to be using a library called Parcel. We'll open the documentation here, this first link on pip.org. This is just a package distribution. So you can grab the name of Parcel, come back and go to the documentation right over here. This is what it looks like. We'll come back and we will install it. And the reason we're using Parcel is because it's going to be a little bit closer to Scrapy framework that we're going to cover a little bit later. But Scrapy utilizes Parcel, Parcel utilizes LXML, and then Parcel also has some additional features like using regex, which we're also going to cover a little bit later. For now, let's go ahead and install Parcel. You can see my virtual environment is deactivated because I don't have venv. Let's say venv scripts activate and then pip install -requirements. And by the way, here we have two parsers. Usually you would roll with just one. You don't want to have Beautiful Soup, Parcel, LXML. You don't want to have the whole house. Choose your tool specifically, try to use just them. If you necessarily need to bring something in, do it. Getting the job done is probably a little bit more important. Coming back to main.py, dropping down the terminal, let's get BS selected opponents. We will copy paste it, remove the copy, and then we'll replace select with XPath. We will jump back to the Parcel documentation and we're going to try to use it. First, we're going to see from Parcel import selector. Let's copy that, come back, and actually let me zoom in here so people can see it. Replace BS4 with this selector, and then we have some kind of HTML and we pass it to the selector. So we're going to be replacing soup with selector and text with HTML. The rest of it is getting to know XPath and actually substituting these actions. If we want to get something using the CSS selectors, there is an option to do that in Parcel. If we are trying to use XPath, you have to use the .xpath method. And here is an example of XPath, a little bit more verbose than CSS. So the first question, maybe like, why the hell would we want to use it? Why the hell are we learning it anyway? The same way that we've learned that Beautiful Soup was Python specific and you can only use it in Python. CSS selectors are for web developers, people that are writing web pages. They will essentially mark up nodes for you to know where to collect from. But from their perspective, we're just styling them. From your perspective, they're doing the hard job for you of marking where individual data is. XPath is even more generic, where it works on the family of XML data structures. Let's take a look at what XML is. We will just Google for it. We'll go to images because I don't know if I can just find a piece of text, but here's an image. This looks oddly similar to HTML, and that's because it's the same kind of representation of the data. It's the same family. XML is the daddy and HTML is the child. So if you're using XPath, you have the option to parse HTML and XML. If you're using CSS selectors, you are restricted to HTML. A question may come around, how widely is XPath used around the internet? Not very widely. RSS feeds will use it. If you don't know what an RSS feed is, you're probably a little bit young. You can Google for it, but that's an example of where you would utilize XPath because XML would be returned from there. Otherwise, it's mostly HTML, so CSS selectors will probably have you covered. However, XPath is still something valuable to learn because it gives you that arsenal of not only working on XML and HTML, if there is any other variation of the same family, you can parse all of those as well. You can look through the examples that they provide here and you can Google for XPath, see what you find. I'm going to close LXML tree and I'm going to close Beautiful Soup. We're going to come back to the Khabib Nurmagomedov page and let me find the table again. Open up the developer tools and let me find the table yet again. Right over here, we're going to press the selector on his last match and focus in on this table. If we right click on the table and then press copy, same as before, we attempted to copy the selector. Let's just copy the XPath. Let's see what it looks like. Control F, Control V to paste what we've just copied. And this is what it looks like. Just to give you a little breakdown, globally search for any element with an ID that equals this, then go to the first div and to the third table. We can replace the search for the third table with saying that class equals wiki table, and that will also bring us to the same table. Notice that we're saying at ID and we're saying at class, whereas if we would be using CSS selectors to reference an ID, we would use a hashtag. To reference a class, we would use a dot. This is just an example of how CSS selectors live in the web development world, where ID and class are these specific things that you can look for. With XML, these are basically attributes. So we're not looking for ID, we're not looking for class, we are looking for attributes, for example, like style, that will contain something like font, size, and then 85%, semicolon, and a little space, and we'll be able to find the same element. Notice how we're not finding this first table. We can, again, go back to class, double click here, get all of the classes, and replace the string here. We're looking for a class that equals to this string value. It's not that XPath is being able to distinct these individual classes, it's that it's just saying, here is a value, and I'm comparing class to this value. As far as XML is concerned, a class is an attribute, and that is the value. In HTML world, in web page world, classes are individual space separated identifiers for somehow styling your page or giving it some kind of contextual meaning. We have some additional functions that we can use with XPath as well. For example, let's just search for XPath. You may find something like W3 schools, and that may just solve all your problems. You also have cheat sheets, which is what I generally prefer to use. And I will look for something like functions or something like that. Can't remember what it was. So contains. Here is an example of the function. We want something that contains a class head. If we go to table, contains a class, that is going to be the first parameter of the function. And then we'll remove all of the classes here. So we're left with wiki table. And I'm going to put a closing brace here. And now we're also selecting the first table. Notice that we have 6 search results. This is where I'll say Look, I'm just looking for a table with a class of wiki table, and that's my table. We have two of these tables, so when I'm gonna search for this, even with this big XPath, I'm gonna get two back. So the select one option that we've been using with Beautiful Soup may not help us here. However, let's see what will happen if we will remove all this stuff at the beginning and just put an additional slash. Double slash being we're looking anywhere in our HTML document for a table that has a class of a wiki table. We find two elements. This is where you will just need to use your logic. Which element do you need? The first one, the second one. Here it's the first one. Let's grab our XPath expression. We'll come back. We will use the selector here. Coming back to the documentation, just so we remind ourselves, if we want to select by XPath, we have to use the .xpath method. Instead of select, we say XPath, and then we specify the XPath. This is going to give us a couple of tables. We will then grab the first one. We can actually put the index over here. Putting it here prevents us from putting if statements here and checking, have we actually got any tables at all? And if the array is empty at this point, we're going to get an exception. I am willing to go for that risk. Okay, we're going to get the table with matches, and then matches. Again, we're going to try to use XPath. If I just put // I'm going to research the whole document. And just so you know what this is going to look like, I will return length of TRs at the end, and we're going to see it printed. Additionally, I will just print the TRs. Let's rerun the application. Python main. We get a valid result because we've never substituted this strategy. Coming back to main.py, we will duplicate this line, comment it out, and replace select with XPath. We'll rerun the application, and we're gonna see 103 TRs being selected. Again, it's researching the whole HTML document from the root. And when I say root, that means this HTML element anywhere in there where there is a TR, we'll bring it in. Notice that we have 29 and 0. Khabib had 29 matches and a header TR, so that is going to be 30. We're looking for 30. In the XPath cheat sheet, again, you can just skim over it, see what kind of things you're looking for, try them. Eventually, you will stumble on something upon this, which is relative navigation. So you place a dot to say, I want to start from the current element that I'm at. That's what we're going to do. We're going to go back to XPath. I'm going to close BS select opponent. I'm going to say, from the element that I'm currently in, search everywhere for a TR element. We will rerun this, and we're going to end up at 30 TRs, which are going to be all of the opponents plus the header. Let's remove all of that malarkey, drop down the terminal, and we're going to be doing things a little bit different. Force our initialization to happen at the beginning, where we will have the link straight over here with none, so we never need to do this. And if and when we collect link, we'll just put it into the opponent object that we have here. We will do the same with the name. Put a comma on the end. This code could remain the same, although we're only setting the opponent link here. So let's grab this, cut it out, place it over here, and remove this line of code. Opponent name, because we do have to do a little bit of pre-processing on it. I don't mind setting it here. However, firstly, select one. We need to fix this. Again, we're looking for a TD third in a TR element. So in TR, let's use XPath. We're gonna look for TD third element. Remove the nth child, and that should be okay. We can also use dot to make sure that we're specifying from the current element. If we go back to practice this, right over here, we will go to table. Looks like that is no longer being found. All right, because we don't have a table. We have a T body, we then have a TR, and inside that TR, I want to grab a TH, let's say that is in the third position. So that's what that's going to look like. Additionally, to actually just skip the node instead of performing this check, we always know that it's going to be the first, this header node. And one way that you can practice these things is by just opening up Python. This is going to open up a live REPL standing for read, evaluate, print loop. Here we will define a collection that says 1, 2, 3. And if we try to grab the first one or the 0th index, we get 1. That is understandable. What if I want to grab 2 and 3? Well, I can say that I want to start from 1 and make sure that I specify that I want to start from 1. I have to put a colon. This kind of lets me specify the range for which I want to select out of the collection. I'm going to get all of the other elements, excluding the first one. Again, if I specify the start to be at the second element, I'm just going to get 3. I can also do it the other way around by saying up to the second, or in this case, up to index 2. So 2 is 3, non-inclusive. Start is inclusive, end is non-inclusive. If up to index 1, we only get the index at 0. So when we iterate through TRs, what I'm going to do is just say skip the very first element. This is going to let me just ignore what is happening here and not have to specify this if statement. Let's put a little space on the top here. From the opponent node, we get this string. Is that the same thing that happened in parcel? Let's check it out. We'll go to using selectors, search for everywhere where it says XPath, and look for an example where perhaps it may get the text. And here is what we see. We see some kind of selector and then we get. So here specifically it refers to the text of the node. We'll try to call get on it straight away, see if we will get the text or if we need to zoom in on the text straight away. I'll call get here. I will print this opponent name. I'll then comment out the rest, not adding anything to the array, so it will return an empty one. And to exit this terminal, you will want to press Ctrl+Z, enter, rerun the application by python main.py. And here we can see that indeed what we're looking at are individual elements. Getting the text is what we want. Let's try that. We will go to XPath on the node. From here, we will get text. Let's rerun. Like that's an invalid expression. Let's just remove the dot here. So we're specifically in the TD, we want the text. Here's what we get. Notice a bunch of nuns. That is because of the link. The other check in that sense is still relevant. We'll comment this out, remove the print. If we are getting a none of text because there is an anchor, let's get the anchor out of XPath. We'll get the XPath. Coming back to the documentation, notice how it tries to get the src attribute at src, just specifies that. So we want a at src, just get that. That's going to be our link or source. And actually, sorry, for us, it's going to be href. That's what we're getting there. We'll call it link here because it's no longer just an A. We'll place it in the curly braces here. That's going to be the constructed link out of the opponent node XPath. And oh, I forgot to call get here. We also want to extract the text. After we call href, let's call text. Uncomment the last bits where we're appending the name and the opponent to the array. We'll come back to the terminal, press enter a couple of times, up and rerun the application. Looks like we're failing on the image collection. I'm curious to see why. We're gonna grab the anchor this way and we'll try to see, is this valid? Okay, print A, rerun the application, scroll up a little bit and it looks like nothing is being printed here. That is giving me a suspicion of we're never really entering this if statement. So that means that opponent name is never actually none. Let's double check that it is never none. Print opponent name equals none, rerun. And there we have it, false. If it's always false, maybe we need to change our strategy a little bit. We have the opponent node. How about we try to see if it has a link? Take the opponent node, XPath, and we will extract a link from it. This is going to be a link. Let's comment these two lines out and actually the rest as well. We will print here, link, rerun. For some of these, we see that there is a link that we can extract. For those where there is no link, that is when we can supply an opponent name out of the text. Let's say if length of link, so how many links have we gotten? If it's 1, we want to do this extraction. Otherwise, we want to set the opponent name to the opponent node text. Otherwise, we'll grab this code over here, move this, place it over here, and select all of this, uncomment. And by the way, if you're wondering how I'm uncommenting, I'm using Ctrl/keybind. I don't know if you are going to have the same, but that's what I'm using. We already have the link, so no need to use this. We can select the href here from the link. So instead of using the opponent node, we use link, XPath, just select the href. Let's get that. Apply the href over here, or relative link. That's going to be that. We're still doing the sanitization here. So we will uncomment the usage of opponent name so we can see it. We're working on the link here. So remove a slash. Remember that this is an array. This is not going to be a single link. These are going to be anchors. If we have anchors, we will then have an anchor. And that's the anchor that we want to work with. Okay. Rerun the application. And it looks like we're ending on the same result, where we have links for those fighters that do have links and the fighters' names. Looking good. Let's save this and take a look at collecting an additional piece of data. We will ask, was this a win or a loss? Maybe an outcome. Come back to the web page, to Khabib, and let's take a look at what the first row looks like. It may say win, and that's good enough for me. I'm just gonna grab the first element. This is going to be a win node or even a win condition. Look for the first one, get the text, get, stick that in the opponent. This will be the outcome. Rerun the application. Look at the data that we've collected. Here we have win. Again, we have this new line thing going on here. Let's drop down the terminal, use the strip on the thing that we get, rerun, look in the data that we have collected again, and looks like all the data we're collecting is pretty good. Thank you very much for watching. This will be it for this video. If you have any questions, leave them in the comment section. Don't forget to leave a like, subscribe. Also, if you want to say thank you, leave a comment, or even better, get the source code on my Patreon. Big thank you to all of my current Patreon supporters. Your help is very much appreciated. Thank you for watching the video, and have a good day.